Okay, so we've drawn the given plan. We've located our spectator from corner A, and we've drawn in our cone of vision, hitting the extreme ends of the object. Our next move now is to find the line of sight. Now to do that, we must bisect the angle that's created by the cone of vision. So in your compass from point S, where it cuts the cone of vision on either side, don't change the distance of your compass, describe another arc, same on the opposite side. When both those arcs now cross paths, will give you the half of that angle, or in this case, our line of sight. So from S through the line of sight, or through that half angle, is our line of sight. The question tells us the picture A touches corner A, or the picture plane touches corner A, therefore we know that if we go perpendicular to our line of sight through A, we'll find the picture plane. If you have an adjustable, this is where this guy comes in really handy, because he speeds up your work quite a bit. So I'm just going to set my adjustable up to my line of sight. And now it'll allow me then, well, it won't either actually, so it won't go down far enough. Okay, so you won't go down far enough, so I'm going to have to go back to the sliding set squares. So one set square to your line of sight, slide them back, put the other set square flat against them, make sure he's running through A, and now we can draw on our picture plane. Okay, so that's the picture plane in. Our next trick is to find our vanishing points on the picture plane. This is easy enough done, as the rule is consistent regardless of the question. So what we want to do is follow the path on our plan on both sides to where it hits the picture plane. So what I mean by this is from S, going parallel to where it hits the picture plane. I'll show you a vanishing point on the picture plane, and the same the opposite side. So from S to where it hits that picture plane. That's going to give us VP1 along the picture plane, VP2 along the picture plane. Okay, so back to our sliding set square. Make sure he's still set up. He is perfect. So now we can bring our lines down, as we will need to find the vanishing point on the horizon line. So it's best practice to try and draw the ground line first. That way you know how much space you've left when you want to draw in the horizon line. And the question tells us that the horizon line is 40 millimeters above the ground. Measure it 40, and again draw them in. These lines are parallel to the picture plane, so the angles don't change. Now we need to drop down VP2 and our VP1 to where it hits the horizon line. So we need to find the vanishing points along it. So I'm just going to extend these lines out. That's going to give me VP1 on the horizon and VP2. No, horizon line, ground line. Okay, so next thing we want to do is bring this line A straight down to hit our ground line. Because it touches the picture plane, all the lines that we draw off that will appear to the same measurement as given in the elevation. So make sure that the lines are only moving parallel with your VPs down from A to hit your ground line. Set them up. Okay. Next we need to look at the question to find out what the heights are. So back to the elevation. Overall height in our elevation is 70 millimeters. Measure up 70. And I want to vanish. Back to VP1 and VP2. So this is the bottom. Vanish back. And the top. Same to VP2. So this now becomes our top of our object, the highest point on the bus stop. So I want to find out where it ends along this side, so I'm going to bring down this point. I want to find where it ends coming this way, so I'll bring down this point. So they're already connected to the spectator, which saves us the trouble of doing so. So where they intersect the picture plane, we are now going to bring them down. Again, we're still moving parallel. I'll drop him here. And I'm going to do the same then with this guy. So we can see that these are our two endpoints. So let's darken in what we know we can so far, which is not an awful point at the minute, but we can darken in this line here. We can darken this line to here. Now, to find the height of this back part of the bus stop, because it's not sitting along the line that touches the picture plane, we must bring our line from our plan out to where it hits the picture plane and bring him down parallel, so he then becomes a true height line for us. I'll extend him out to where he hits the picture plane. And he comes down, parallels to the VPs, the same as all our other points have done so far. Let's just bring him up here. Okay, so now I extend my ground line that wee bit further. Catch it. And I know from looking at my elevation but the measurement I need to go up is 50 for the back of the bus stop. Measure up 50, catch it, and I'm going to vanish him back to VP2. Where that cuts here gives me the inclination of the back of the bus, which I can now darken in. Okay, so now we're darkening this back line here. And we know that this guy is going to connect here, so we can be darkened in. That is as much as I need to darken in at the moment. So we know that the bus stop is hollowed out, so we're looking back in at it. So I'm going to have to bring this point here and vanish him back to VP2. Somewhere along this line is going to be the edge, and that can be found by vanishing this point here back to my vanishing point. We're still missing one point, which comes here. I need to find this back wall. So all we can do to find the back wall is drag this point here from the back wall of the plan down to the spectator. Where he cuts the picture plane, I'm going to bring him down to our perspective. See here is our back of our bus stop. So I can now darken in the last couple of lines along to the bus stop. Up as far as this line here at 50, which we found earlier on. It also gave us that angle there, and it also gives us this angle to join back here. And that is our bus stop. One more line left. Fully complete. So this was an ordinary level question that came up in 2011.